Hi. How do you force an AI to actually think and give you better results? Why does understanding one simple concept, tokens, separate the amateurs from the pros? And are your long chat sessions secretly making your AI dumber? I'm Chris, your best guy of AI, and I'm going to teach you how to think. A single key phrase can be the difference between a complex problem being solved incorrectly or with much greater accuracy. Whether we start a new conversation or continue an existing one also has a huge impact. This all stems from how language models operate, so before we think about thinking, we need to go a level deeper. We know we can break down any sentence into units like words, syllables, or sounds. LLMs, however, break them down into units called tokens. I will use a tool called the tokenizer to break down an expression into its core components. Tokens are not words, syllables, or individual letters. They are chunks of text isolated by the tokenizer. They can be whole words, parts of words, or in some languages single character might be made of several tokens, or even punctuation marks. Each token is assigned a vector which captures the meaning of that piece of text. It's an encoded fragment of text with a meaning that is understandable to the AI. There are also special invisible tokens, and sometimes role separators can also be tokens. Generally, shorter words may constitute a single token, while more complex words can be composed of several. Depending on the LLM we choose, each model tokenizes text differently. This depends on factors like the model's sophistication, its training data, and the specific tokenizer it uses. In the documentation provided by OpenAI, we can find a comparison showing how different GPT models handle various languages. We can see that the models understand English so much better than other languages, that smaller models can sometimes provide more accurate answers in English than more advanced models do in another language. This documentation contains other interesting insights as well. This is a direct result of the data the model was fed. If we translate the same sentence into different languages, we'll observe a different breakdown into tokens and different total count, which can be much higher for languages other than English, especially with GPT models. Never tokenizers have reduced these differences, but English remains still more token cheap. How a language affects token generation isn't a perfect comparison of understanding, but it can indicate a certain level of optimization. For this reason, other models will be better at understanding a specific language. This is due to their training content and data. Many countries have developed solutions that excel in their native language, like Bielik for Polish, Qwen, DeepSeek or Ernie for Chinese, or the multilingual Mistral. The most well-known companies also create versions for specific countries and languages, Sweden, India, and so on. Although differences in responses to less complex queries may blur depending on the language, but it's something to keep in mind. During the learning process, a chosen word or token is compared with others to see how well it fits. The token is then assigned a vector, a set of numerical values that captures its semantic context in many dimensions, which is actually hard to define directly in a process called embedding. For example, the word stewardess may be semantically linked to words like woman, human, or employee, but also to airplane, air, travel, or suitcase. Such a vector contains hundreds or thousands of dimensions that encapsulate the token's meaning. LLM components called transformers have revolutionized pattern and relationship detection between words, allowing for simultaneous processing of many tokens. This enables a much better grasp of context. Through a property called self-attention, the transformer determines how important each token is in understanding the overall phrase, how crucial it is within the content for our comprehension. Then, the model's task is to predict which token will best continue the response to our question. These potential next tokens are assigned a probability of occurrence. They are selected based on their connection and context with other tokens until the LLM successfully completes its response. The tokens in the response are generated based on all the input tokens, the ones we provide, and the tokens already created by the model in its response. This single piece of information reveals a lot of crucial insights for us. Everything we wrote in the prompt matters, and it's taken into account. A few key tips. First, be clear and specific about what you want. If the context doesn't require a specific conversation tone, skip it. When seeking a solution to a problem, avoid exchanging pleasantries with the LLM or insisting on a particular format. Instead, focus on the quality and informational content of the prompt. The more detailed you prompt, the more accurate the answer. The more general you are, the less precise the model's response will be. Second, be aware that the model can get anchored by the information you provide. If you don't want to suggest a specific solution, try to maintain a balance in the information you provide. If you are looking for a list of smartphones with certain specification but have asked about specific models in the same conversation, you can expect those models to be suggested in the answer. At this point, it might be better to start a new conversation. Remember that some models can remember information about you, including your preferences. This is often desirable to establish context, but it can also lead to suggestions based on the past data instead of focusing on the current prompt or other sources. Third, the length of your conversation and the amount of information you provide matter. Just as a random mistake in a long prompt may be not significant, crucial information can also get lost. With a large amount of data, the response might be more general or less accurate, but it could also take more factors or contexts into account. If you need a summary of a specific chapter, without any mention of information from other chapters, you don't need to provide the whole book, just the selected chapter. It's important to know when to end a conversation, for example, when you want to ask about something completely unrelated. The size of the context window, how much information you provide, is significant. Fourth, don't overload the model with too much information in a single query. It's often better not to ask for everything at once. For example, if you want the model to answer 3 complex questions, ask them separately rather than all at once. In each query, the model will focus on one question and give you a more precise answer. When generating the next tokens of a response, the tokens generated so far by the LLM are also taken into account. Each generated token is added to the current context. The inking property is based not only on the user's tokens, what it has remembered from us or other sources and data, but it also uses the tokens it has created itself so far. It's as if we start a thought process. How do I make a pizza? We would think about what's needed. Based on that, we'd realize we can make dough from flour and water, stretch it, and then add cheese, mushrooms and tomatoes. But knowing we have whole vegetables, we'd conclude they need to be sliced and the other ingredients prepared. Only then can we formulate a precise answer. We need the ingredients, then we need to prepare them, only then can we assemble the pizza, right?
Yeah.
But what happens if we add that short command to just get the final answer? We'd expect a precise and accurate result without the fluff, right? Well, not exactly. We'll likely get just the answer as requested, but it will most likely be wrong. Let's analyze a problem involving the optimization of a single logic function whose result should be 1, as derived from its transformation. In one case, we'll ask for just the result. In other, we'll ask to explain or break down the problem. We can see that where we only have the result, it's incorrect. What is more, if we continue the conversation with the same query, we'll still won't arrive at the correct result. Especially with logical, mathematical or analytical problems, we need to break the problem down into its constituent parts, which might require different methods to reach a solution. Very often, a single phrase like "let's think step by step" will trigger a multi-stage thought process that considers the problem's complexity. Triggering such a process is a technique called chain of thought. You can force this process with various prompts. The exact wording is up to you. A prompt isn't like a rigid command interpreted by a system. You can experiment and gain experience over time by interacting with the LLM. It's more like talking to another person. Prompting isn't just copy-pasting. A single token of word can completely change the result, depending on the context. Understand how LLMs work to write good prompts. We can also induce the thought process in another way, by providing an example with a line of reasoning. Before we get to that, there are different techniques for providing examples: zero shot, one shot and few shot. Zero shot, as the name suggests, is providing only the query without any examples. This is a good method when you don't want to bias the result and expect a simple, general, untemplated answer. One shot is adding a single example to the prompt with the expected outcome. It works well when you require a specific response format or a particular method for solving a problem that doesn't involve highly complex processes. The model focuses on one example, which systematizes the process. Few shot involves a command and several additional examples to help the model arrive at the result for a more complex problem, outline possible solutions, or establish context for the query. You can present different methods for reaching a solution, as well as different data and results. This not only adds another way to solve the problem, but also creates a context where there isn't a single right method. We can combine these techniques with COT. Without adding an example, you can trigger the reasoning process with phrases like: think step by step, perform a deductive process before giving the answer, or even explain how you arrived at the solution. You can also outline the reasoning process in the example itself. It also triggers the model's thought process. You can also combine this with multiple examples. You are not limited to just one or two. There can be many, depending on the need and the complexity of the problem. In your examples, you can also specify what results you don't want, and even justify why a certain result is wrong. To solve a math problem, you can provide an example of a similar problem with a step-by-step solution. Providing an example also increases the precision of our query. I will repeat myself. What matters is the number of precise tokens, their ratio to the rest of the content, and a coherently defined context that fits the query. There are other methods for producing precise tokens. Tree of Thought allows the model to explore several different lines of reasoning, compare them, and choose the best solution. Additionally, there's a hidden self-evaluation aspect here, where the model has to critique certain solutions. Analyzing different thought processes and selecting a result will increase the precision of the answer. Yet another method is to prompt the model to ask you questions for clarification. Sometimes we don't know what other specific information we can provide. The model can help us with that. By answering the AI questions in the same conversation, we'll get a result based on the precise tokens we provide. This is also a great way to refine the context. That's a lot of methods, right?
Yeah.
Don't worry, this is not programming, where precision has to be more higher. You can treat these techniques like Lego bricks to build a great prompt. Which method to use and when? It depends on what you need. If you want a math problem solved correctly, it's worth adding COT. If you want a quick, simple answer to a simple question, maybe just asking it directly is enough. If you want the AI to do something exactly as you wish, give it an example. How to use a given method. This isn't programming. You can describe what you need in your own words. Moreover, you can freely combine all of this in various ways. How to remember them all? You don't have to. You just need to understand how you can influence the result and the thought process. I'll talk about other ways of arranging the bricks in another video. Writing prompts is above all about practice. The more you try, the more you will learn. Write a lot, continue conversation, close them and open new ones. Try new methods, have fun. It's like learning to talk to people. If you only read a language textbook, you won't learn to communicate fluently with another person in that language. In this case, practice is what brings the theory to life. You have to manage an experiment. Feel free to share your own discoveries and techniques in the comment section. I will tell you about one more great method, especially when you are starting out and when you need to formulate a long, very precise prompt. It's asking an LLM to write a prompt for an LLM. Yes, I know, it's mind-blowing, but it works. This way we can describe what we expect and then copy the AI-generated prompt into a new conversation to avoid anchoring it to what we wrote before. This is a game changer where we are not quite sure what we want or how the model will perceive it. This method is very often used for models that generate media, and you can always ask the model to improve the quality of what it wrote or to modify it. You might also find that you want only the final result without the visible thought process. You can add a note to the prompt for this process to be done in the background, invisible to you, but be careful. Very often, the model can't generate tokens that are hidden from us. And in this way, you might kill the every thought process you wanted to trigger. Many models have a built-in thinking property. Nevertheless, as the data shows, it's still worth focusing on writing a good prompt. Data, in this case regarding the Claude model, indicates that the model performed better with an prompt, not just by triggering a line of reasoning. We observe a simplified relationship between different methods. Adding a thinking process and a precise prompt significantly increase the quality of the response in this case. But can triggering such a thought process ever be a bad thing? Other sources suggest that while there are significant improvements up to a point, the accuracy of the answer can decrease with an excessive number of tokens created during thinking process. This leads to an effect called overthinking. More isn't always better. Generating too many tokens can be limited by the architecture of a given model to prevent it from getting too chatty. Furthermore, generating too many tokens can significantly increase the cost of using paid versions via API. As the number of tokens used increases, the precision and quality of the response may decrease. Sometimes you might want to deliberately repeat yourself by writing the same thing in different words. If you really want the model to grasp a detail, focus on something specific, or add emphasis to the context, you can do this. But be careful, you can also harm the model's response this way. A healthy balance is key. How can we prevent the model from overthinking, maintain more control over its response, and maximize precision? Set specific constraints. Provide concrete numbers, values, or examples. Ask for 3 solutions to compare instead of a few, or for a list of 5 items. Even define tasks with specific values. Instead of propose an expensive solution, say propose a solution that costs $100,000. Instead of ask me for details until you have enough information, say ask questions until you have 95% of the necessary information. Define the framework. Write 4 sentences. Come up with a title no longer than 32 characters. Let your response have an introduction, a body, and a conclusion. Try to be precise and don't confuse the AI with contradictions or overly complex constructs. One more important thing. It turns out that where information is placed also matters. Some models may pay slightly more attention to the beginning and the end of a prompt. The most characteristic feature of an LLM is that it considers the entire conversation, but it places the most emphasis on your current query. The LLM uses the conversation so far. But if you give it a completely different command, it will try to execute it, sometimes forgetting about the entire conversation. If your next query is too general, because you assume the model will connect the dots and stick to the conversation, you might be unpleasantly surprised. Even if you ask the same question before, it's better to repeat it word for word, unless you are experienced and the conversation has been well directed, in which case you can sometimes afford more general statements. In short, the LLM focuses on executing the last command, or an earlier one if you are continuing the conversation coherently and referring to previous queries. This property has another interesting side. It can be a method for us to obtain information or trigger a desired action, but it can also be a threat and cause an unexpected result. Let's say we want the LLM to do something against its pre-programmed restrictions, like giving us information we are not supposed to get. This is called jailbreaking. In most cases, the response will be restricted. We can also use a technique called prompt injection. With many simple models, we can force the intended action. Might be able to convince a sales bot to ignore its initial prompt and give you a recipe for biryani. We can also distract the model with a specific task that causes the information to become visible to us, or the task to be executed despite the rules. Remember this in the context of privacy and security as well. Parameter tuning, structures, assistance, rules, privacy, speed, advanced prompting. All of this awaits you in another juicy videos.